The question 4 is to use power series to approximate values of transcendental functions. Transcendental functions means some functions which is difficult to solve. Say for example, this is one of the basic example of transcendental function, sine x equals x. You can't directly jump and tell the answer, We need to do some trial and error. In calculator, it's possible, yes, but these are not simply solvable by addition or multiplication, so they are called transcendental functions. Even e to the power x and something like this, these are all transcendental functions. Now we will be using power series. Look at this, e to the power 0.5 is needed to be approximated. Of course, you can put this in calculator and get the answer, but they've clearly mentioned do it till 3 decimal places and use exponential series. You might remember Taylor series, Maclaurin series. They have given the power series over here. We can solve it easily. I'll write the formula for exponential series. So e to the power x can be given as over here. It starts with 0, n is 0, and it goes until infinity. X power n divided by n factorial. This is the easiest of all. Now, it's better to write this in the formula because it's a writing exam, right? This is the formula. And then the expansion is just plug in the values. If you put 0 over here and 0 over here, it'll be 1 by 1 plus. Now, if you put 1 and 1, it'll be x to the power 1 by 1, that is x. Plus, if you put over here 2, it'll be x power 2 by 2 factorial plus x power 3 by 3 factorial, and so on. It keeps on going till infinity, till n goes on till infinity. But here they have told fifth partial sum. That means you need to have 5 terms. 1, 2, 3, 4. Let me write one more. That is x power 4 by 4 factorial. 5 terms are there. If they ask you, say, sixth over here, you need to write till x power 5. 6 terms, see, because 1 and x 1 is there. Then we start with x power 1, 2, 3, 4. So 1 less than whatever is given over here. So now then we will, how do we solve it? It's very, very easy. We will just substitute instead of x, what do we have? 0.5, isn't it? So here what happens is 1 plus 0.5 plus 0.5 squared divided by 2 factorial plus 0.5 cubed divided by 3 factorial plus 0.5 to the power 4 by 4 factorial. Now you might be thinking we are going to use a calculator. Yes, we'll be using calculator, but these can be solved even without a calculator. Say 0.5, the whole square is 0.25. You can even over here try and get 0.625, and you can ultimately solve it without calculator. That is the thing. But now for your exams, use your calculator instead of wasting time. You can directly put this entire thing in the calculator and solve it up. I remember power series was there for me when I did my first year engineering. The thing is, we used to solve many problems at once. So what we did is we just put this in the scientific calculator like this in terms of x rather than putting the substitution. Just put it in terms of x, that is x squared by 2 factorial, that is shift and this symbol over here, x inverse. But press shift and x inverse, you'll get it like this. And plus x cubed power 3 by 3 factorial, and lastly we have x power 4 by 4 factorial. Now in your exam there'll be only one problem, but even though instead of typing in 0.5 each place, you can just put this out and now calculate it any value. Which value? Over here it's 0.5. So I just put 0.5. The answer is over here, that is 1.64, and they told 3 decimal places. So 1, 2, 3, it's 8. This is the answer. So that's how easily we can solve this problem. Now I'll leave that over there. I can use the same thing to solve any other problem. I'll show you in a minute. So this is how we do it. Now if you write so much, technically it should be full marks, okay? Let's just look over here what they have done. Okay, this is a mistake. It should be 4, only this much, okay? This last term must not be there. Fifth partial sum would be 1, 2, 3, 4, 5. That's it. And then what do we have is they have done just the first term, second term, third term. So it's not sixth term, it's fifth partial sum. Apologies for that. This term is disregarded, only five terms. And then we add those terms up and then we approximate it. Okay, now the reason over here is they have taken more values. Over here, the answer is 1.649. The actual answer would be 1.648, which we got, because we have to take only fifth partial sum. So be careful. If you take more, then the answer varies. See over here, they have taken 1 2 3 4 5 6 partial sum. Your answer is 1.649, which is incorrect. Okay, if you take fifth partial sum, it should be this. When I was preparing this solution set, I did not pay much attention to the solutions. I just clipped it and posted it. But this is the actual answer, and you can see over here. There we go. Similarly, any other problem, just to check the answer, calc minus 0.25. That's it. And that will be the answer. That is 0.779. The three steps which I'd written a while ago, these are suffice. The formula, the substitution, the answer. This is very simple. The series, exponential or trigonometric series are just like this. But what you need to do is write the entire formula, write the clear substitution over here. You should put minus 0.25 and remember to put the bracket here when you write it out, because this is positive. I didn't write the brackets. And then you get the answer, round it off to 3 decimal places only. Now, if you want the next answer, just press calc minus 2.5. And here we go. The answer is 0.648. Similarly, please do try all these answers. I'll just check one more. It's 0.8 over here. And you can see the answer must be 2.222. And yes, that's the answer. So this is it. This is how we can easily solve all these problems. Now here, let me just try this. 3.5. Absolutely, this is the correct answer. Now we have a real world problem. Let's look into this problem here. The population density P per square meter of zebra mussels in the upper Mississippi River can be modeled by P equals 3.5 e to the power 0.8 t, 0.08 t, where t is measured in weeks. Okay, that's the time in weeks. Use the fifth partial sum of the exponential series to estimate the zebra mussel population density after 4 weeks, 12 weeks, and 1 year. So it's the same thing which we'll have to repeat it. Now I'm just going to use the same thing because I'm just lazy to write it out again. This is the formula. I hope you remember. Now, there is a bit of change. We don't have just e to the power x. What we have over here is, so we need to change this up. And the answer will definitely change. What we have over here is 3.5 e to the power 0.08 t. I will take first one at 4 weeks. At t is equal to 4, it will be multiplied by 4 over here. So you can just start solving like this. What is it going to be? 32. So it will be 0.032 here, 0.032, or you can write 0.08 times 4. It's up to you. It's positive. This is power 2, 0.032, 0.032. But this is not the answer. We have just done this part. This entire thing is multiplied by what? 3.5. So this will be the answer. This will be the proper substitution. Because we have some factor, the coefficient is multiplied. The formula for e to the power anything, e to the power x, is given by the exponential series, which is written up over here. I hope you can see that. And the substitution is over here. Now we just put this in the calculator and get the answer. I'm going to use the same thing, because it's just 5 terms, it's the same terms which we have used a while ago. I'll just multiply it by 3.5. That is this term. And what do? We need to calculate at 0.08 times 4, or you can write it as 0.032, up to you. The answer must be 4.81. Let's just look into the answer. Now they are rounded off to the nearest 10. They didn't tell it, right? Estimate. Yeah, they didn't tell it. But over here, they have just rounded off to the nearest 10. You can keep at least 2 decimal points. What I would write is 4.82 instead of 4.8. Now, if you want 12 weeks, all you need to do is, okay, I just realized one thing. I did an error over here, 0.0 I wrote. It's 0.32 only. My bad for that. Okay, that's the answer. When you multiply over here, it'll be 32 because it's two digits. There'll be 3 and 2 over here. So I just missed that out. Okay, this will be the substitution. For the next one, you have to multiply 12 times 4. So, sorry, not 12 times 4. 12 times 0.08. This one, instead of 4 now, we have to take 12 weeks. Let me write it out. At t equals 12, it'll be 3.5 e to the power 0.08 times 12. And similarly, you can do the substitution over here as well. And for 1 year, you need to take 52 weeks. How many weeks are there in a year? 1 year is always equal to 52 weeks. So this is the substitution for the last one. Now over here, what do I substitute is 0.08 times 12, and the answer would be 9.11, which is rounded off to 9.1. And lastly, calculated at 52 times 0.08, because 0.08 is the coefficient of t. So t varies. It's 52 this time. And last one is 134.0. So this is how we can solve this problem. All the exponential series are very easy. Now let's move on to the power series for cosine and sine functions. Now this is also not that difficult. I'll just write the formula. This is sine, right? There are two different formulas. I'll do both sine and cosine problem. Over here we have the similar thing. It's always from n0 to infinity. Now this is a little bit tricky. It's minus 1 power n, which is there even for cosine function. But the x, right, this is 2n minus 1. This is odd. Odd numbers are denoted by 2n minus 1. And down also we have 2n minus 1 factorial. Multiples of 2 are always even numbers, isn't it? Minus 1 would give you odd numbers. Now if you expand this, I'll just write it down over here. This is basically for sine x. So sine x is given as, over here, the first thing, when you apply 0, what's going to happen? Now, you do not need to, memorize all this all the time. Over here, it'll be 1, and over here, if you substitute, basically, you will get x when you substitute 0. And then next one would be, see, now, I'll write the formula and then I'll explain it. X power 3 factorial. I just remember sine is odd, cosine is even. This will be x power 5 by 5 factorial. Then we have x power 7 by 7 factorial. How many terms? Fifth. 1, 2, 3, 4. Let me write one more. X power 9 by 9 factorial. And this goes on forever. It's dot, dot, dot. So until infinity. Now, always remember, sine function is odd. And over here, the powers are 1. This is 1, 3, 5, 7, 9, and so on. Another thing is, this alternates, the sign alternates, because over here it keeps alternating, minus, plus, and so on. The same thing it is for even cosine, but cosine will do it in a while. I'll show you how easy it is. Once you write the formula, you just have to substitute over here. Sine of pi by 9 equals to, what happens? X is pi by 9 minus pi by 9 the whole cube divided by 3 factorial plus again pi by 9 the whole power 5 by 5 factorial minus this time pi by 9 the whole power 7 by 7 factorial, and lastly plus pi by 9 the whole power 9 by 9 factorial. Now again here as well in the calculator you can write this in terms of x, and then you can easily change it for any given value. Now we'll substitute in the calculator. Again we'll use the x terms. Second term is minus x cubed divided by 3 factorial, that is shift and over here, plus again x power 5 this time divided by 5 factorial. Every alternating term will be negative and positive. So now it's negative x power 7 divided by 7 factorial, and the last term over here plus x power 9 by 9 factorial. So we have 9 factorial shift and this symbol. Now what do you calculate it at? We need to use pi by 9. So let's calculate it at pi, that is shift and pi divided by 9. And here we go, that is the answer. The answer must be, now here in this solution said this is wrong. They have done only three steps, which is error. They have asked fifth partial sum. That means you need to have five sums at least. See, like this, five terms, which I've done over here. But anyways, you'll get approximately the correct answer itself. So over here, yeah, even for 3, the answer is same. But actually, you must do this because you have to write it. All the 5 terms must be written, then put in the calculator, and your answer is 0.342. Here, it doesn't matter if it's in radian or in degree, okay? Because x value is considered directly over here, like a value it's considered. Even if you take pi by 6, it'll be 3.14 divided by 6, and that's substituted over here. You can ignore that because we're not dealing with angles especially. That's the reason. So this is how we basically solve it up. And next one is cosine. The formula varies just by little. Let me just show it out over here itself. See, what happens over here is we had odd number, that -1 is now removed, and over here as well -1 is just removed. So it is just 2n. So it's very easy. Once you know one of the formula, the other one will be very easy. This is cosine. Even numbers will be there, even functions. So that's why you have x to the power 2n and 2n factorial. This remains the same, everything else. Now what happens when we substitute? Over here there is no x term and there is no odd terms at all. See, all will become even. So even over here, you will have to change all this. And over here we have changed it anyways. So let me just raise this completely down one. So the first term is 1 minus, here it will be even, 2, 4, 6 and so on. So over here that's 2, then we have 4, we have 6, 8 and so on. Now the signs will remain the same, minus, plus, minus, plus. First one is plus 1 minus x squared by 2 factorial here. 4 factorial divided by 6 factorial, 8 factorial, and it goes on. But we have just been told fifth partial sum, so I've written only 5 terms. Now what is, okay, this is not sine, it is cosine. Okay, so I've just, erased and written just over there in the previous formula itself. This is all cosine. Now, what is the given question? It's 2 pi by 13. Doesn't matter what is the x value. You just have to do the substitution. Over here, it'll be 2 pi by 13, the whole power 2 divided by 2 factorial, plus over here as well 2 pi by 13, the whole power 4 by 4 factorial, plus minus over here. Then we have 2 pi by 13, the whole power 6 by 6 factorial, and lastly plus it is 2 pi by 13, the whole power 8 by 8 factorial. Now this everything needs to be put in the calculator. I'm just going to change this because otherwise it'll just take too much time as well, erasing and writing it. I'm not going to write this substitution. I'm just going to write x so that we can use it for any of the formulas. Over here, x squared by 2 factorial, that is shift and this symbol. And we have to add it up with x power 4. Use the fraction symbol. Sorry, I pressed alpha and that's the reason. First press the fraction symbol, then alpha and x power 4 divided by 4 factorial. We subtract it now. It's plus, minus, plus. Next one will be minus. Again, x power 6. It's alpha x power 6 divided by 6 factorial. Now I have forgotten to write the fraction symbol. It's 6, and let me just press next, and now we can write the fraction symbol, shift and factorial, and it's plus x power 8 divided by 8 factorial. And we stop there because they have asked only fifth partial sum. There are 5 terms here. Calculated at 2 times pi divided by 13. So that's a given question. And what's the answer? It's 0.885. That will be the final answer. Okay, over here they have written 0.886. It actually is 0.885. Let me, yeah, they have just rounded off the third, but it's 4 here actually. Maybe the reason might be, you know what, they did the five terms like this, individually, and they rounded off over here 333, and maybe that made the difference. But anyways, see, such issues, don't worry, because we will be checking it in the calculator as well. So that's fine, How about this next one? Next one, it's sine formula. We have to change the formula entirely, and I'm very lazy to do that. But I'll do the cosine problems. Look at this one. Let's calculate it at 3 pi, shift and pi, divided by 10. And the answer is 0.588. Because it's 7, it'll become 8. Also, there might be this over here, it's 86. It might be the reason that instead of pi, they have taken 3.14. Over here, 2 times 3.14 divided by 13. So sometimes that might also lead to a small minute error. As we can see over here, it had to be 885, but it's written as 6. Same way over here, the next problem can be done as well. Oh, it's all gone now. But anyways, this is the same formula you can use, the same substitution. It's just that whatever x value is given, you substitute and solve it up. So please remember the steps. They are very important. Just 3 steps. It's very easy as well. Now, please solve all these by yourselves and then check the answers here. Now we have some reasoning questions. 52 to 58 is all reasoning. Writing in math. Describe how using additional terms and approximating series for e to the power x affects the outcome. Okay, what it means is, see, now we have solved for fifth, over here it was fifth partial sum. And even the previous problem for fifth partial sum. But what if we added few more partial sums, maybe sixth or seventh? It just gives a better approximation. We get more closer to e to the power x. That would be the answer. The sample answer is, in general, using additional terms provides an approximation that is closer to the actual value. Absolutely. As you go towards infinity, you'll get the exact value, but you can't go to infinity. But as you increase the number of terms, you get a better and better answer for e to the power x. Now here, another thing is, use the power series for sine to explain why for x values on the interval minus 0.1 and 0.1, the close approximation of sine x is x. Okay, first let's write the formula for sine x. I'm not going to write the entire summation notations and everything. I know sine x is directly x minus x power 3 by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus x power 9 by 9 factorial, and it goes on. I've just written 5 terms. Now what they're asking is, okay, I get what they're meaning. See, let's put 0.1 over here. What happens? 0.1 minus, when you cube it up, right, 0.1 to the power 3 divided by, this is going to be very, very small. It's negligible value. As it goes on, see over here, power 5, this is completely negligible. It's 0.000001 divided by 5 factorial. It doesn't make much difference. And again, you're dividing. It's, equivalent to 0 point something, so many zeros. Even over here, it's 0. So practically, if you see the values from 0.1 to negative 0.1 to 0.1, all the values within this are very small or minute, tiny values. So these all are negligible. So what remains is sine x is x itself. So that's the reason. Because we can just test it in the calculator. Wait, I'll show you. Here, let me write this. Let me write at least few terms only. It's minus x power 3 divided by 3 factorial. And then we have plus x power 5 to the power 5 divided by 5 factorial. Okay, that's a wrong symbol. Over here we go. Now I will calculate it at 0.1. Look here, it's practically the same thing. I put 0.1, it is 0.01, 0.099. If you approximate it, it'll become 0.1. That's what they are saying. If you put in any value, let's try 0.05, which is within this range. Now the answer is almost 0.05 itself. 499, it'll be 0.05. How about 0.01? 0.01, it'll be, let me write it out over here, 0.00999, which is 0.01. See, that's the same. Whatever you input the x value, the same answer you're getting, because these are very small approximation. They're like 0.000 some answer, so we can ignore them. Let's look into the sample answer. As you go with the higher degrees, see, as you go with the degrees of 3, 5, 7, the value is very, very less. 1 divided by 6,000 is a very small value. So therefore, we just consider the first term, sine x will be almost equal to x itself. We have a challenge problem. Prove that 2 sine theta cos theta equals e2 theta I minus e minus 2 theta I by 2i. Now, I hope you know the Euler's formula. It's written as Euler. It's pronounced Euler. I will just go through the steps. Okay, there are steps. I'll just run down these steps. Okay, instead of writing them by myself, I'll just tell you what is happening in each step. This is given. We are just writing the given. Now you need to know for e to the power anything ri or xi or theta I, we have Euler's formula that states for any real number x where imaginary is also there in the power, you write it as cosine x plus I sine x. This is the formula. Now here what do we have is, instead of x we have theta. Okay, that must be the answer, right? But look here, there is another power 2, so that means this is power 2 squared. If it's squared, it will be multiplied to itself, right? Now, how do we write this? This is e to the power 2i theta. So the same thing if you take the power. But now what happens? We know only the formula for this one, ix without the square. So if you have to square this, we have to square on both the sides. Therefore, we write the formulas over here. Can you see this? Cosine, instead of x, we have theta, plus I sine x, instead of x we have theta, minus. Now here, what is the thing? It's minus. So if it is e to the power ix, but minus is there, then the answer would be cosine x minus I sine x. Instead of plus, it becomes minus. That's the only difference. So we got these two. Now then, what do you see? This 2 by I is just written separately. We are just solving these things down. Here we have this in terms of a plus b the whole squared, that is equal to a squared plus 2 times ab plus b squared. So let us just substitute that. Here, what happens? Okay, I'll just do the substitution for the first one. It's cosine square theta plus 2 times I sine and cosine theta. And then we have plus I power 2, because we have to square both the terms, and sine square theta. What is I squared? That is equal to minus 1. I is square root negative 1. I square is minus 1. So here, instead of I square, you put minus 1 the whole square. And this I squared will be just minus 1. So therefore, this is same. Here, this becomes minus, because I square is minus 1. And then we write sine squared. Same thing here at the right side. It's cosine squared theta minus 2 times I sine squared theta. And here, it is really plus over here, but this I squared becomes minus. That's the thing. And now then we will see what can be solved. This is minus, it can be solved, cancels off. Here we have minus, and then this minus is multiplied here, it becomes plus, right? This is also cancelled. You're only remaining with 2i, and this minus and minus becomes plus. So you're only remaining with 2i sine theta cos theta, 2i sine theta cos theta. When you add them both, 2 plus 2 is 4, I sine theta cos theta. Now this I is cancelled with I, and 2 one time and 2 two times. So it will be 2 sine theta cosine theta. So that is basically the derivation. You can see this, everything is there in detail. So whatever I've written over here is just some, where the formula is applied, but not exactly told how this becomes minus. So I just written that step. Everything else is pretty straightforward. So from Euler's formula, we prove this theorem. So yes, we get 2 sine theta cos theta. Both the sides are equal, right? Hence proven. What about this question? For what values of alpha and beta does e to the power I alpha equals e to the power I beta? Explain. Now again, it's the Euler's formula. We have just done it a while ago. Instead of x, we have alpha and beta. Now over here you can see which are common terms, like which are equal to each other. The real part will be equal to real part, the imaginary will be equal to imaginary, because they have clearly told they are equal to each other, alpha and beta. So they are equated to each other, right? But what happens? Cosine and sine functions, when do they repeat themselves? At 2 pi, right? So here you can see the real part is cosine alpha equals cosine beta, sine alpha and sine beta is the imaginary part. And what we need to remember over here is alpha is equal to beta, yes, at when? Every 2 pi, at every positive integer of 2 pi. Now here this n means it's integer, not only positive integer, sorry, it's just any integer. Even -1, -2, -3, it's possible, or 1, 2, 3, 4, 5 is possible. So this is what this means. So basically the answer is at what values of alpha and beta does, they are equal at every 2 pi interval, I guess. That should be the answer. Let's look at the final answer. Yeah, that's let's okay. If alpha and beta differ by an integer multiple of 2 pi, then the complex numbers represented by e to the power I alpha and e to the power I beta will be the same. The imaginary part also will be the same, because it's sine. Both are trigonometric function. At 2 pi, the trigonometric, that's the period of sine and cosine. So that's the reason. So here you can see that's the answer. Over here, it's just written in detail. You can see everything is written in detail and it's solved. There's another proving problem. We need to show that this is real. This is true for all real numbers x. Let's solve this one up. If you look up over here, you should remember this is Euler's formula. Now let's just only take this one, because I can work with this and try to get these two terms. So let me see. E to the power ix minus e to the power minus ix. By Euler's formula we have cosine x minus, sorry, it's plus, over here it's positive, I sine x minus, see this is the first term done. I'll write in big brackets the second term, cosine x minus, because the sine is power is minus, right? I sine x, big bracket closed. Now we'll multiply the minus sign inside. It's going to be cosine x plus I sine x minus cosine x plus I sine x. We can cancel the cosine and minus cosine. They cancel off. I and I add them up. It will be 2I sine x. It's like 1x, 2x will be 2x. 1 and 1x will be 2x, right? Same way we have I sine x 2 times. So we get 2I sine x. Now this is all equal to what? Yeah, we have got 2I. This is all equal to e to the power ix minus e to the power minus ix. What do we have to prove? Only we need sine x. So divide both the sides by 2I. We get the proof. This cancels. So basically e to the power ix minus e to the power ix minus over here divided by 2 multiplied by I is basically sine x. That's the answer over here. So that's how we can solve this particular problem. Let's look into the steps over here. Yeah, it's the same thing. They have just taken the two terms and used the Euler's formula and simplified and got this given term. This is what we had to prove. Again, it's the similar thing. I would ask you all to solve it by yourselves. It's just cosine. Now, same thing, Euler's formula substituted over here and simplify. We get 2 cosine x. Remember, when we had sine x over here, we had got 2I sine x. Look at this one, it's plus here. So when we add it up, cosine and cosine becomes positive, because the second term, I sine x and minus I sine x, cancel off. You'll have 2 cosine x and take 2 to the other side. You'll have cosine x is equal to e to the power ix plus e to the power minus ix by 2. The last problem, it's about hyperbolic functions. We need to prove these two are true. So again, I'll just run through them. As you know, power series over here, they can be expanded. We have to derive these formulas, by the way. So here, how do we derive is basically take what is sine hx, cosine hx over here, which was given over here, right? And we use the formulas. What formulas we use is power series, not Euler's number, because there's no imaginary part. Now don't think, okay, can I use the Euler's series, Euler's formula which we just used? No, because there is no I, so we can't use cosine plus I sine x. No, we have to use the power series of exponentials. So expansion is given as we did it at the beginning, right? 1 plus x squared. We have to use this. If it is power minus, what happens is wherever there is odd powers, see here it's minus, here also it's minus, minus. What happens? Minus x remains. But when you square it up, it becomes plus. So we have plus here. Whereas this becomes minus. Wherever odd powers are there, it will be negative and even powers will be positive. So after getting this, let's put it back into these equations, both of these equations. It's just lengthy, but it's this easy thing, you know. We substitute everything back over here and then try to solve. Look over here, they have minus in the middle. So what happens is all this positive terms go off, but this minus terms become plus here now. Positive becomes minus, gone. This becomes plus. So basically what you're having is you're having over here 2x cubed by 3 factorial, such terms. Look over here, 2x cubed by 3 factorial. If you add more for the terms, the power 4 will be cancelled because minus plus, right? But this one will remain. And now then, we have divided by 2 in the given. See over here, this is divided by 2, isn't it? So when we divide everything by 2, this 2 is gone. So you're getting the formula for sine hx, that is hyperbolic function. What is the difference? Look over here, it is almost same. Only thing that is missing is minus 1 to the power n. It's not negative alternating. See, that negative sign is missing. For sine x only, what we had x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus 7 by 7 factorial. That is alternating positive negative, but over here in hyperbolic, no, there's no alternating, it's all positive only. So even over here in sine x we had summation from n equals 0 to infinity, but we had important thing minus 1 to the power n. Then we had odd numbers, right? Sine is always odd, 2n minus 1 and 2n minus 1 the whole fact. So it's, you know, plus 1 or minus 1, you can take it either thing, because we start with plus 1, sorry, not minus 1. We did this for sine, but extra part was only this minus 1 power n. So that is the only thing missing with the hyperbolic functions. Same thing can be done for cosine functions. The same thing is repeated over here, and you can see this is what we get, and absolutely same, only the minus 1 the whole power n is missing here as well. So that's the answers. You can see the hyperbolic function for sine is given over here and cosine is given below. So that are the answers, the expansion formulas. And that's the end of question 4.